All right. So I guess how many of you here know Wolfram language? Some of you, not many of you. It's fairly easy to learn. It's it's a language for mathematical people. It's a language for Mathematica. So it follows what you already know for your math functions. Some key detail is the function arguments are specified using square brackets. But I think you can kind of read through it and understand. Here, I'm naming a function, e phi. That function takes two arguments, x and theta. Good? And what I'm specifying here is this. E naught, some kind of amplitude, times a complex exponential. This capital I is the imaginary number. Complex exponential times 2 pi over lambda times x sine theta. What am I writing down here? What does this function, so if I write it out in the usual mathematical notation, it would be this. I don't know. E sub phi is equal to E naught, e to the I, 2 pi over lambda times d, times x sine theta. What am I writing here? What is this function? Electric field, right? With this, this is my phase factor. This is my phase factor as a function of distance x from some reference zero position. Good? So that's the function I'm defining. I'm defining this because I'm going to use it to specify my electric field from slit number 1, zero phase, electric field from slit number 2. I set it to be 10 wavelengths apart. Good? All right. So, so I think this is calculation we have done in class. So what I'm doing here is I'm adding these two complex functions, superposition principle. And this absolute value function in Mathematica, it actually does the complex absolute value. So it does the complex function times its complex conjugate, square root it. So that's what I'm using here, and I'm squaring it because it's actually the square I wanted. Good? So let me run that. So that's the series of calculation I'm doing. This all that you're doing is I'm taking whatever expression comes out and I'm simplifying it. So, and when I do that, well, this is what I get. And this is a function you have seen, right? Cosine squared of the phase factor. That gives you the double slit intensity pattern. And let me take this and plot it. I'm just going to set the amplitude to be, or the electric field E naught to be 1. Then when I plot it, from minus 0.2 radian to 0.2 radian, this is what I get. That's the double slit intensity pattern. Good? That makes sense to everyone? All right, so this is in programming class. So there's a reason I went through this. It's because I'm taking this and using it to do n-slit calculation. To do this by hand, it gets very tiresome at some point. So what I'm doing now is I'm using this software to do this calculation automatically for me. So along the way, what I'm making sure is that my code is written correctly. I'm putting in the values that where I know what I'm expecting to get, so that I'm making sure that I didn't make a mistake. So let me just explain some of what I'm doing here. So this is the same function you had for e phi before. I haven't changed that. Now what I'm doing is I'm setting the distance between the neighboring slits. Same distance I used before. Now what I'm doing is instead of defining 2 electric fields, I'm defining n electric fields. So if I let I go from 0 to 2, then I actually goes from I equals 0 and then I equals 1. And I think it stops there. It doesn't actually ever become 2. So that's the table of list of electric fields. Right now it'll be list of 2. So let me just, total is the summation of everything in the list. And let me uncomment this so that you can see the calculation. And let's see, if it gives me what I was expecting to get. So that seems reasonable, right? Yeah. It looks a little bit different from what we had here, but I think with enough trigonometry, you can prove that this is actually same as that. Power reducing formula, all that stuff. Good. All right. So when I take this and plot it here, then you should get the double slit pattern. Wait, what? Sorry, I guess I misunderstood. It must be 0 to 1. All right. Sorry. That's why I'm double checking. So look at the pattern. All right, so that's the double slit pattern. So I guess what it must be is, let me do a quick check. So I'm going to have it actually print out E-list. Yeah, so here so these are the two electric fields. So this is the double slit. If I wanted a triple slit, then I would let I go from 0, 1, and then 2. So 3 electric fields, and so this is what I get when I plot it. And now it's a lot easier to see, because so with the triple slit, I see a minimum here and here, here, and where I get maximum, it hasn't changed from last time where it was. And let me just do it for a couple more. Let's say 4 slit. This is what's in your textbook, and so this is the 4 slit pattern. And I can keep going. And the nice thing about this is that you can go beyond what's in your textbook. I can do 5 slit. Oops, not 56 slit. I can do 5 slit. So now it's beginning to get complicated. So at some point, I'm going to start showing stuff. So this is what happens with the 5 slit. All right. Now I want to do 10 slit, or rather, yeah, I want to do 10 slits, so let me actually start hiding some stuff, because it's going to start getting complicated. I'm not going to show the whole table. You'll just have to trust me, it's 10. And I'm going to actually comment this out, because the simplifying thing, it'll at some point take too much time. And the expression won't look all that simple anyway. So, so if I want 10 slit, then I want this number to be 9. All right, let's just plot it and see. So whatever mathematical expression it is, it's going to be complicated. But what I can do is I can just see what it looks like and get some conceptual sense that way. Instead of trying to look at some mathematical feature, I can just look at the plot and see if that makes some sense to me. Yeah, I mean, I can't really count, but there's probably 9 minimums there. What are you beginning to notice as I'm plotting this? Do you notice anything, I don't know, remarkable? It's getting narrower, right? Let me just go one more step. I had a 10. Let's do 100. I haven't tried it before class. I think it's going to work. It's actually not all that computationally intensive for Mathematica. For me, it is. So that's with 100 slits. Yeah. You see it getting sharper and sharper and sharper.